methyl, methyl ether. So both of them have the same formula. Both of them have the same number of carbon, same number of hydrogen, same number of oxygen. But they are differing in functional group. So they are called functional isomerism. Functional isomerism. So in isomerism we have seen chain isomerism, position isomerism and functional isomerism. When the isomerism has been arised due to the difference in carbon length, chain length, then it is called chain isomerism. When the isomerism has been arised due to the position of functional group, different position of functional group, it is called functional isomerism, position isomerism. When functional group itself changes, it is called functional isomerism. So far we have seen the alcohols having one OH group. Now we are going to see the alcohol having more than one OH group. Look at this one. You know very well that it is ethylene. It is ethylene. Suppose two OH group have been added. One OH here and another OH here. Simultaneously, two OH have been added across double bond. While two OH have been added across the double bond, one of the bond breaks. It is a simple logic in organic chemistry. Whenever, actually it's an addition reaction. Whenever two groups attacks two carbon connected by double bond, one of the bond breaks. So one of the bond breaks and you have got a new compound. Of course it is obtained from ethylene. It is called glycol. Since it is obtained from ethylene, it is called ethylene glycol. It has two alcohols, two alcoholic group. So it is also called diol, D-I-O-L. Suppose this is the one carbon and second carbon. Both the carbon of ethane are connected with OH, two OH. So it is called 1,2 ethane diol, 1,2 ethane diol. So ethylene glycol is the common name, 1,2 ethane diol is the IUPAC name. Suppose, let's see this one. Yes. It is propylene. It is propylene. Suppose one OH attacks here. Here one hydrogen is replaced by OH and the double bond becomes single bond. Now you have got another diol. Suppose if you count like this, 1, 2, 3. Among these three carbon, the first and third carries OH. That's why it is called 1,3 propane diol. Diol, two hydroxy groups. That's why it is called diol. It is called propane 1,3 diol or 1,3 propane diol. Both are same. So we have seen the alcohol having two OH group. Now let's see alcohol having three OH group. CH2OH, CHOH, CH2OH. Of course, it is prepared from propylene. It is called glycerol. Glycerol, glycerin, all are synonyms. It's a trihydric alcohol. Basically propane, and all the carbons are carrying OH group. So it is called propane 1, 2, 3 triol. In the previous case, we have written diol 2 OH group. It is triol 3 OH group. Shall we go to another one? So what all we have seen are aliphatic alcohols, open chain. Now we are going to see closed chain, aromatic alcohols. You know very well that this is the benzene. Suppose it is connected with OH, it is called phenol. Its formula is C6H5OH. It is phenol. C6H5OH. Suppose the benzene connected with CH2 and OH, it is called benzyl alcohol. Benzyl alcohol. Its formula is C6H5CH2OH. Suppose these are the aromatic alcohols. So when OH is directly connected with benzene, it is called phenol. When OH is indirectly connected with benzene through CH2, it is called benzyl alcohol. Now let's see like this. CH3OH. You know very well that it is methyl alcohol. IUPAC name is methanol. Suppose one of the hydrogen is replaced by phenyl group. So it is called phenyl methanol. Yes, your guessing is correct. It is phenyl methanol, nothing but benzyl alcohol. It is benzyl alcohol. So phenyl methanol is the IUPAC name of benzyl alcohol. Phenyl methanol is IUPAC name, and benzyl alcohol is the common name. So we have seen the different kinds of alcohols and how alcohols can be. Now let's see the preparation of primary alcohols. How the alcohols have been prepared. What are the sources from which alcohols are prepared? Alcohol can be prepared from alkene, especially secondary alcohol. Secondary alcohol can be prepared from alkene. For example, this is propylene. This is propylene. Double bond is there. On the left hand side of double bond you are having 2 carbons. On the right hand side you have 1 carbon. In the left hand side 1 methyl group is there. Since different number of carbon atoms on both left and right, it is called unsymmetrical alkene. What's the meaning of unsymmetrical alkene? If the both the side of double bond carries different number of carbon, it is called unsymmetrical alkene. So it is an unsymmetrical alkene. In this case, suppose it has been treated with water. in the presence of H2SO4. You could have learnt Markovnikov's rule in +1. Markovnikov's addition. The Markovnikov's addition claims that the negative part of the addendum, H2O is the addendum, its negative part is OH. The negative part of water will go and attack the carbon having more substituents. Among these two, which is having more substituent? The middle one. So, the OH attacks the middle carbon. Out of H2, when OH attacks the middle carbon, one hydrogen has been remaining. It combined with 2 hydrogen. So 2 plus 1, 3. It is nothing but isopropyl alcohol. So from propylene, you can get isopropyl alcohol. It's an unsymmetrical alkene. Suppose you are having symmetrical alkene. This is symmetrical alkene. CH2, double bond CH2. Nothing but ethylene. Suppose ethylene is there. It is treated with sulfuric acid at 353 Kelvin. Straight away, one H attacks the first carbon, so CH2 becomes CH3, and another one CH2 HSO. Out of H2SO4, one hydrogen attacks the first CH2, and that CH2 becomes CH3. And the remaining HSO4 attacks the remaining. So up to this, it is called ethyl, and it is called hydrogen sulfate. So it is called ethyl hydrogen sulfate. Ethyl hydrogen sulfate. Further, this ethyl hydrogen sulfate is hydrolyzed with water. While hydrolyzing, the ethyl group combined with OH